YouTube. Okay. I really need to make a new YouTube thumbnail. It's really old. Okay, but anyway. Number 7, a block with mass m starts from rest inside on a plane inclined at angle theta. The coefficient of kinetic friction is mu, which expression correctly yields the block speed v after it has traveled a distance d down along the plane. Wait. Is this the same situation as up here? Oh, never mind. There's no spring. Jed first on YouTube? What goes down doesn't have to go back up, I guess. I feel like there's some crazy... I mean, if you're attached to a spring... then, you know, you'd have to go back up. Okay, so I can see... Why is that there? I can see on the right side, we have kinetic energy in every scenario. Now, block with mass m starts from rest sides on inclined plane at angle theta. And so we're doing d along the plane. And so the vertical distance we care about is d sine theta. So that's where the mg d sine thetas come from in those expressions. Now for the work done by friction. So I think how I would think about this is at the very beginning we only have gravitational potential energy, mg d sine theta. And after we're making d sine theta, I guess, our 0 point. So once we've expended all of that potential energy, it's going to have whatever kinetic energy we have plus something to do with friction. Whatever heat has been generated by friction. And the force due to friction is what, like mu n? Coefficient of friction times the normal force. And it's going to involve a cosine theta of the normal force, which is why that cosine theta is there. They're all mu mgd. I feel like it's going to be A. Well, no. Sorry, it's going to be B, right? I'm still trying to justify... I'm just kind of looking at the signs. Mu in the normal force is mg cosine theta, and you're integrating it. Wait, where does that? Shouldn't there be a sine theta in here too? No, there isn't, because we're just traveling a distance d. Yeah, okay, so it's The normal force is mg cosine theta. Mu, that's a normal force. You multiply by mu to get the force due to kinetic friction. And then you integrate that from 0 to d to get the work done by friction. And that would be in addition to the kinetic energy, but they seem to have, I guess, you would solve this expression for V, and that's why they added the friction force over to the left side, or it subtracted it. So I think B is the answer. I'm gonna, 8 is the last multiple choice question, so I think we'll go through 8 as well before we check the answer. Cart with massless wheels contains sand. The cart starts at rest and then rolls without any energy lost due to friction down into a valley and then up a hill on the other side. Will the initial height be h1? Final height attained on the other side be h2. The cart leaks sand along the way. Okay, that's why they're doing this thing with sand. How does h2 compare with h1? It's a good question, Morin. How does it compare? I think we only need to worry about M1. Our initial potential energy is M1G H1. And we know at the very end it's going to be equal to M2G H2. If we know, or M1 being greater than M2 implies H1 is less than H2 in order for these two numbers to be equal, because we already know that G is equal. So I think that's our answer. Why are they doing it backwards? Okay, H2 is more than H1. That's the important thing. Okay, so we're saying B and C for 7 and 8. Are we correct? B. Okay. That's what I said. B? What? Okay, wait. Well, let's make sure that I did do logic for number 7 right. Well, let's find out where I got confused on number 8 after. Okay, so I did the alternative approach. That's fine. Really? The league sand has kinetic energy when it leaves the cart. Its kinetic energy eventually ends up as heat when the sand comes to rest on the ground. What? Oh, and good. If I want to make my head hurt like it wasn't already, you can consider the more difficult side where the cart has massive wheels, which we assume will never slip on the ground. So it requires material from chapter 7, so you need to wait until then to think about it. So hint, the answer is not that they're equal. in torque. Interesting. Cart applies no force to the sand. Hence my Newton's third law, the sand applies no force to the cart. Damn, that's an incredibly tricky one. Wow. All right. We're on to the regular problems here. Okay. In an effort to make the world a greener place by reducing the burning of fossil fuels, consider the following alternative method of producing energy. This brilliant method applies the principle of hydroelectric power to normal solid matter. Hey, Red Dot, I'm good. How about you? Welcome in. The plan is to blow up the sides of mountains and convert the lost potential energy of the flying rock dirt into electric power. Okay. That's something. Texas find very roughly the volume of rock that needs to be converted daily to satisfy the entire world's need for power. You need to look at the values of various things, such as the world's daily energy consumption. Assume that some ingenious method has been devised to capture all of the energy of the falling rock. Assume that on average the rock falls a height of 1 kilometer. Chill, that's good to hear. Right now I'm just doing some physics studying to see if, until someone comes in with like a question they need help with. Okay, well, let's start with the global daily power consumption. I don't like having the freaking AI thing at the top of every Google search. What is it, Red Dot? Terawatt hours. $27,064. Ah. How do I make text smaller in this program? Why isn't there an easy way to do that? Okay, well, we're just not going to include the entire link. What year was it? 2023, 27064. Wait, I already forgot the number. 27064. Wait, really? It was 064? Not okay. It was 064. Terawatt hours. Terawatt hours. Power. Hey Rex. I'm not getting radical. So what happens when you times 1 by itself? Semantic question asking 6 root 7 times 5 root 7. Oh yeah, we can definitely talk about that. I don't think we need this analysis thing anymore. Delete you. Delete you. Okay, so you are multiplying 6 root 7 times negative 5 root 7. Here I would use, it's called a commutativity, but the actual name's important. Just if this is all, this is the same exact thing as 6 times root 7 times negative 5 times root 7. So when everything is multiplication, you can rearrange this in whatever order you want. And I think this problem is a lot easier to do if you do 6 times negative 5, like group the things without the radicals together, and then group the radicals together. So times root 7 times root 7. And so 6 times negative 5 is negative 30. And then root 7 times root 7. The trick that always, well, okay, look. There's two ways you could think about this. If you have a square root times the square root of the same thing, you're just going to get whatever's inside the square root out. So root 7 times root 7 is just 7. There's a couple ways you could think about that, like root 7 times root 7 is the same thing as root 7 squared. And squares and square roots, they undo each other. So you could also think about it like this, or you can do it yet a third way, which is this works for any time you square root times a square root. You're not 49. 49 will be involved here in this way that I'm about to show. Root 7 times root 7 is just 7 though. And maybe this third method will make that more clear why. If you have a square root times a square root, you can combine them underneath one big square root. 7 times 7. And that goes for any combination of numbers. It could be 5 times 7 or x times 7 or whatever you want. And so you could call that, or you can say 7 times 7 is 49, so that's the square root of 49, but then, oh wait, the square root of 49 is just 7. This is a little bit roundabout. Well, like I wouldn't do it, if I had root 7 times root 7, I will just go directly to 7 personally, but this is the way that, or this third way is always true for any combination of numbers you want. So if you had root 5 times root 6, you could say it's one big square root. 5 times 6 is root 30. So 49 is involved in this math, but it's the square root of 49, which is 7. You see it now? Awesome. And then just because I can't help but finish the original problem off, 30 times 7 is 210. Yeah, exactly. No worries, red dot. Let me know if you run into anything else. Oh, and thank you for the follow. And since you're a new face, whenever I do see someone new around here, I do like to let them know that if you ever need help and I'm not around, there's a whole like little niche of people who do math help out there on Twitch. So if you ever find yourself in need of more help later, there's a whole list of people who also do math help. And hey, oh my gosh, I remember we agreed, or we agreed how to pronounce your name, and then I forgot it now. Maddie Enge, I think we said. Conceptual question got my head hurting a bit since yesterday. I'll leave it here so you can help me, or we can have a headache together. Can light orbit a black hole? Spectre is saying, I believe it can and does, at least what I've heard, kinda. No worries. Red Dot. Thank you very, very much for the question. It's so. I mean, I think I hope we can all definitely agree that light is affected by the presence of a black hole because they have a bunch of gravity, and that affects light. But literally orbiting, I feel like it would. I feel like there's no reason why not if there's a light ray at the perfect angle. You can technically see the back of your own head if you haven't come that close to a black hole. Wow. I mean, I definitely wouldn't know the. I definitely would not be able to speak authoritatively on that, but you can see what Google says. Light can orbit a black hole. It's only possible exactly one radii, the innermost bound circular orbit. That wraps my understanding of the topic. The possible orbit for light is therefore an unstable circular orbit. Interesting. So it can't stably orbit. Accumulation of light and therefore energy around the black hole. That sounds convincing. I'll drop the link to this in chat, but I imagine that someone like physics and depression or like Dr. Cook or someone will be able to give a way better discussion on this because I don't really know the first thing about it, to be honest. This article seems interesting enough, though. Around a black hole, light moves along null geodesics. There are trajectories through space-time that have the total length of exactly 0. That hurts my head. What is a length of 0 if it's not just the same point? Light can trace out parabolic trajectories, circular orbits, or trajectories that inspire into the black hole. Oh my god, this article is massive. I only just now noticed the scroll bar. Okay, I'm not reading all this. Okay, yeah. That's an interesting question, Mediange, but... So it's about the most that I can say about it, I think. I'm just over here struggling with my mechanics. This question makes your head hurt. I'm satisfied. Sounds good. Thank you for the question. World's daily energy consumption. So I guess the question is basically asking, how much potential energy do you need to match 27,064 terawatt hours of power? But obviously, energy and power aren't the exact same thing. You do have to... Hey, Lucas, why is 2 plus 2 equal to 4? Well, as far as I know, that has like a 100-page essay detailing why 1 plus 1 equals 2, and they're probably still working on the probably 500-page essay on why 2 plus 2 is 4. 2 plus 3 coming next, yeah. Sequel no one asked for. Uh... How do we go from blowing up mountains potential energy to generating power? Oh wait, we're talking about for a year, right? Do we... Oh wait, daily. So if I have... Oh my god, I need to think about how the units work here. Wait. Whoa, whoa, whoa. What number is this from? Is this net electricity consumption worldwide? Is this the total amount of power used for the entire year? I guess we want to divide that by 365 to get daily energy consumption. And 2023 was not a leap year before anyone asks. Net electricity consumption. Okay, I'm just trying to make sure this is like for the entire year, and it does look like it is. So what is 27064 over 365? 27064 divided by 365. 74, we'll call it 74. This is physics. We don't need to be accurate. $74 terawatt hours per day. So I need to like power is, well, it's joules per time, right? Joules per second. And a joule, mgh. Mass sorry, mass is kg. That's why I was getting confused. Mass meter per second squared times meter. Kg m squared. Is that seriously s cubed? Sorry, I should say a watt is a joule per second, right? Wait, so if I have a terawatt hour, oh my god, how do these units work? That is energy, it's not power, right? Yeah. Okay. I didn't need to do that stuff on the right. Okay. We have 74 terawatt hours is equal to something involving joules. Is what we ultimately want, right? So maybe we want to convert this. We want to get the terawatts to just regular watts, and we want to get the hours to seconds. Hey, Bhavya, it's going good. How about you? Okay, what? Tera power of 10. What power of 10 is tera? 12. So 74 times 10 to the 12 watts times 360 seconds? Is that right? Yeah, okay. 3600? You're right, Spectre, it's 60 squared. Thank you. Okay, so we want to do 74 times 36 times 10 to the 14 watts per second, with which that is a joule. The white screen maybe wake up. 74 times 36. 2664. I'll round up to 27 and put another 2 powers of 10. I already forgot what number I said I was going to round it to. 27. 27 times 10 to the 16 watts per second, or watts times second. I do know, yeah. Because now we can just say this is 27 times 10 to the 16 joules. By the way, it's this problem up here. It's from a physics textbook that I've been working through. This one is kind of a funny one. Normally they're a bit more traditional, I would say. That is a lot of joules. So we're going to take 27 times 10. Oops, that's not 10. 10 to the 16 joules and set it equal to the volume of rock. Okay, well, we need to solve for the mass of rock, and then we'll estimate what that volume would be. Mass times gravity, which is, we'll call 9.81, just 9.8 meters per second squared, times, and we're saying average of 1 kilometer, so 1,000 meters. So we can solve that for mass. 27 times 10 to the something, 16, divided by 1,000 in parentheses times 9.8. That is, oh, I wasn't even using proper scientific notation. I did 27, not 2.7. Oh my god, bro. 2.8 times 10 to the 13. Work energy theorem? I guess, but yeah. I don't. I only half know what I'm doing here at best. Okay, so maybe how should we like average volume, or sorry, average density of a rock? Grams per cubic centimeter? What is cc? If that's not cubic centimeter, I'm... Oh my god. Most of the rocks... cc. It is cubic centimeter? Okay. Miss watching these streams? Well, hey, welcome back in. Bro, there has to be a way to make the text size smaller in this program. I just... Apparently, you just... are not allowed to make your text smaller. We're gonna call it 2.6 grams per... I'd much rather have... Like, cc doesn't make sense to me. I like centimeters cubed. Okay, so 2.6 grams per cubic centimeter. We want to take decimeter cube of or I'm gonna get it into kilograms per meter. Loving the chill music? Oh, good. Glad to hear it. 1 kg per 1,000 grams times 100 cm in a meter cubed. Okay, yeah. And so this comes out to be 2.6 times 10 to the... Oh my god, so this is 10 to the 6 divided by 10 to the 3. So times... Oops. 10 to the 3 kg per cubic meter. Sure. Now let's take our mass and divide it by the density we just found to get the volume that the problem asked for. So 2.7 times 10 to the 13 kilograms. Density is usually rho, right? No, sorry. We're solving for volume. There we go. Over 2.6 times 10 to the 3 kilograms per cubic meter. 2.7 over 2.6. It's about 1, slightly more than 1, I can tell you that much. 2.7 over 2.6. We're just going to call it 1. Because 1.03 times 10 to the 10 cubic meters. Is that a lot? Who knows? Let's go to volume of Mount Everest. Yeah, volumes are cubed. Mount Everest info. There we go. 200,000 Golden Gate bridges. That's 200 kilo Golden Gate bridges, in case you guys didn't know. $90 cubic kilometers. 90 km cubed to m cubed. Because I don't feel like, oh, well, okay. So 9 times 10 to the 10. The volume of Mount Everest is about 9.0 times 10 to the 10 meters cubed. So we'd go through an entire Mount Everest about every 9 days. It also has an Everest-shaped pile of rocks. I'm feeling a weird sense of deja vu with this problem, where like I feel like I've already done this problem before for some reason. Or something really similar. I'll frickin' OBS. I need to figure out why it does that to me. So if we wanted to power the Earth by blowing up mountains and capturing the energy from the falling rocks, I feel like we'd pretty quickly run out of mountains. I don't know how many mountains are on Earth, but I feel like there's not enough. I guess let's see what the answer for this one is. Number 7. So they got 1.3 times 10 to the 18 joules per day. What did I have? I mean, I got 27 times 10 to the 16. That's a pretty big difference. But that's just we're using different sources, I guess. So I'm not going to worry about that. Well, the point is that they don't have the potential energy anymore once they've fallen. How much dynamite would it take to blow up Mount Everest? I don't know. That's a good question too. 50 cubic meters. Wait, what? This is being colossally stupid. Wait, 1 cubic kilometer. 50 kilometers cubed. Oh, okay, so I'm not too far off because I have 10 I have 10 to the 10 cubic meters. So I may be like 10 cubic kilometers or something. We just started with different numbers, but I think we did the same method, and that's the only thing I cared about. Okay, let's look at number 8. Hopefully it's a more... Okay, this is a more regular problem, I think. That one is kind of fun. But, it's definitely not it. Actually, you know, we should Google that dynamite to blow up Mount Everest thing, right? The world has to know how much dynamite would it take to blow up Mount Everest? Yeah, we are not the first person to ask this question. I've Googled much weirder things than that. I'm already on every single list that's available. Oh wait, 20,000 million tons of TNT. If instead we use thermonuclear bombs of the highest yield, we'd only need 344 of them. Well, that seems like the way to go, personally. In 1960, the combined yield of the U.S. nuclear stockpile is about 20,000 megaton, or mega somethings. I guess tons? I don't know. Yeah, easy, Tyler, right? And if you order them through like Alibaba, you'll get that bulk discount, right? Is that how that works? I never actually ordered something from there. Google how to make TNT. Okay, no, that I'm definitely not doing. Is it? Well, I don't. No, it's probably illegal to make it. Yeah. That emote's hilarious. I remember in high school chemistry class we did make thermite, and that was a lot of fun. Thermite's a lot safer though because it's very hard to ignite it. You need basically to set up a chemical reaction that puts off enough energy to ignite it. So compared to something that's a lot more like volatile like TNT, it's safe, but yeah. A platform has a rope attached to it which extends vertically upward over a pulley, then back down. You stand on the platform, the combined mass of you on the platform is M. Well, I used tannerite before, which makes one hell of a boom. Ooh, that's cool. I've only used thermite once when I saw a Vsauce video. Made my class do an experiment with it. Oh, nice. Okay, A looks relatively straightforward. B looks weird. Wait, this is the least important part of the problem, but I insist on drawing it relatively accurately, apparently. There you go. There's my buddy. Here's me. Some kids saying, Jesse, we need to cook because the packets I made were weirdly packaged. What class were you teaching a chemistry class or what? Tannerite has energy-based ignition. Luckily, you can just buy it in the stores around here. Oh, interesting. Huh. I think for the tension in the rope, we can just kind of consider this part as our system. We have one tension coming up, and then we have gravity coming down. mg. And I'm going at a constant speed. Phobos. You mean Denise? Phobos, welcome in. Hey everyone. We're just doing some physics studying. How's your stream? I hope it was good. I did peek at you, and I saw at one point you're doing some trapezoids to estimate integrals. Bobby, you teach all sciences and maths for short-staffed? Oh, okay. We're gonna way up to Gaussian quadrature. Ooh, I haven't heard of that. What said you would make me a math and physics expert in one stream? I'm waiting. Oh, yeah, sure. Peak and flow, you are now a math and physics expert. How do you feel now? Do you feel different? You're clipping that? You think it worked? Amelia talks. I'm a genius? Yeah, there you go. Anytime. Hey, Peach Tea. So yeah, we've just been doing some physics studying. And we also been talking about chemistry classes where we get to make things that go boom. So I remember when I was in high school, we got to make thermite. Apparently we've had some like tannerite happening. Bhavya taught a class where they made thermite. Oh yeah, and this came from the problem I was doing previously, which is, you know, hypothetically, if we wanted a new source of green energy, why don't we just blow up mountains and capture the potential energy from the falling rocks? And so in this physics problem, they made you like estimate what volume of rocks you need to blow up in order to meet the world's daily energy consumption. And I found you would have to blow up a Mount Everest worth of rocks about every 9 days to keep up with the world's energy consumption. Assuming you can somehow capture the energy of the falling rocks, which is kind of left as an exercise to the reader. But yeah, now we're on to a more like normal problem. But yeah, for anyone sorry, I should have introduced myself. for anyone who's new here, I'm Don. I do like math help streams, and then in downtime I kind of study whatever I'm interested in. So I've been on a physics kick, so I've been doing some mechanics studying, and before I was doing some electricity magnetism. I have done abstract algebra, multivariable calculus, and some other things. I don't want to. I don't know. It's kind of whatever I'm feeling like. but the main thing has been physics. Lots of explosions, yep. For tannerite to ignite, it needs to hit with something traveling at least 2,000 feet per second. You have to literally hit it? How fast is a slap? Like, imagine if you could just slap super fast to ignite tannerite. Like, that would look really cool. You probably would lose your hand or something, but 2,000 feet per second. That's probably way too fast, right? That's really... Okay, never mind. Hello, Tyler. Thank you so much for the sub, Tyler. I appreciate you. Yeah, okay, that is crazy fast. That's nearly... If a mile is 5,200 feet, that's like a third of a mile per second or something. Less than a third. More than a third? Or less? It's somewhere around there. Math. Oh, you got an ad in the middle of that. Dang. I was wondering how fast a slap is, because imagine how cool it would be to just slap some tannerite in order to ignite it. But I think 2,000 feet per second is a little too fast to be, like, I don't think I can slap that fast. Sunbury is what, 12? Oh, you know, you're probably right. It's probably somewhere around there. But yeah, no, 2,000 feet per second is probably way too fast to slap. But you would look cool. Okay, this problem, we're moving at a constant speed, so I think we can say that T is equal to mg in response to the tension in the rope problem. And then how much work my friends do, I think we're going to take, I mean, my friends are pulling against the tension force, and tension is just mg. They're exactly canceling, so we can say that my friends are pulling with mg worth of strength or force. And so the work is just going to be mgh, because we're being hoisted up at height h. So I think A is relatively straightforward for that reason. B, on the other hand, is interesting. And it is very important to draw a little stick figure picture here. There's no way to just visualize this in your head. This is definitely how a rope would attach to a pulley as well. Don't worry about it. So how does it work if I'm hauling myself up? I remember this issue came up in chapter 4 as well. We might want to look back at a previous problem from chapter 4 to be sure. But if I am hauling myself up in this platform, how does this force change? Or does it change? We're only given a combined mass from me and the platform. We're not given an individual mass. Ugh. Like I'm debating right now if we would say something about like if the mass of myself is irrelevant. I don't feel like that's right though. I feel like energy wise, at the end of the day, you are still raising a mass m up a height h. So shouldn't the energy be the same? Therefore the work be the same? Is there an issue with my logic? During the quarantine, I made a question on the physics final that was basically you're leaning in your chair while playing on your phone with your online class running in the background. Your mother walks in strapless? Slaps you, maybe? Making you lose balance? Considering the leg of the chair stays constant at its position and you're originally inclined at 60 degrees with the ground, the length of the leg is L, and your mass can be concentrated at L over 3 as M from the bottom. Calculate the change in your kinetic energy. That is a funny question. Don't judge me, English. I'm half asleep. No worries. I think I get the point. I do like that question. Man, online classes are something. Or rather, I should say the style of online class where it's like just the everyone gets on a giant Zoom call, the professor of the lectures, and then you hang up. Uh, those are a little rough for everyone involved. I don't have a convincing argument that this isn't the exact same answer. I wonder if they're gonna pull something slick with saying, "I am now a part of the system," and I need to rage against the machine. No, it's something about like I'm burning calories or something. Don't be smart with me, kiddo, or you're getting another one. Yeah. Okay, famished. It's going well. How about you? Chill and relax a little bit before taking on some more math. Nice, nice. You know, I feel like that there's another type of this question you could ask along that line for like, I remember my mom talking to her siblings a lot about how like my grandma would have a wooden spoon to spank them with when they misbehaved. And you could have a physics question that's like, your grandma can't find her normal wooden spoon that has a diameter of, say, 3 centimeters at the end. The best she can find is a different wooden spoon with a diameter of 5 centimeters. How much harder or softer should she slap for you to experience the same force across the entire diameter of the spoon, or something like that, you know? I feel like the topic of disciplining your kids is ripe with physics situations. That's what I'm trying to say. So invested in spanking questions. You know, don't question what I do, but behind closed doors, Bobby. All right. No kink shaming. No, there's just a story that they love to tell about how apparently the wooden spoon eventually broke and my grandma upgraded to a metal spoon. My uncles at least apparently got into like a lot of trouble, or like they very frequently were making trouble. I think I'm ready to be hurt again and check the answer to number 8. I'm almost positive I'm wrong about B, but I really don't see what else to say. Actually, wait, let's look. I haven't read the answer to B. I'm just reading the answer to A. Let's look at only like the first sentence of B. Donna's freaky like that. You're goddamn right. The word spank like 3 times now. Spank, 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 spank. There you go. Count all those. Tension in the rope is now only mg/2 since there are 2 parts of the rope pulling on you in the platform. Really? The tension in the rope is mg/2. That's getting clipped too. Peak and Flow. Thank you for the follow. Why is it mg/2? Why isn't mg over something else? Or why is it mg over anything at all in the first place? I haven't figured that out. I should think about it as a free body diagram. That's my issue. I think I need to look at the arrows for the tension. So downwards, we have mg. Up here, we have tension, but also down here we have tension. Is that right? No, or is the tension going? No, the tension is going up. The tension is pulling up. Right? Because I'm getting pulled up by the tension. And that's why we have 2t equals mg. So t equals mg over 2. And so, but I assume the work is still, that's going to be 1/2 mgh then. I was thinking of starting a channel for like small streamers on YouTube. I don't know what I'm going to do. Yeah, I'm not sure what that means. Like a channel for small streamers on YouTube? It's like the wire is connected to the wall, movable. I've heard of issues like that before, and they don't make sense to me. I'm sorry. This free body diagram thing makes sense to me, at least, and I think it comes out to be basically the same thing. But I know I've always struggled with that type of argument. Wait, what? You actually do MGH work because you apply your force mg over 2 for distance of 2h instead of h. What? This is true because the relevant distance is the distance your hand moves relative to me? Because each time I pull the rope down, my hand comes back up, and that's where the distance doubles? Oh my god. Huh. Interesting. I don't think it's that. I think it's literally, they're saying it's literally the distance that my hands move. Ugh. These problems are insane. Block of mass M is attached to a ceiling by a spring with constant K. And relaxed length L. Initially, the spring is compressed to a length of L over 2. The block is released. What is below the ceiling will the block be brought to rest? Okay, I'm glad we're doing a question like this, because I remember wondering what would happen with this in an earlier problem. The mean position, I don't think velocity is 0 at the mean position. I think it'll be at rest at the very bottom. I think what we're going to have is U spring plus U gravity initial is equal to final only U spring. So the potential energy of the spring in the initial state is 1/2 k L over 2 squared. The gravitational potential energy is mg and then the variable I named h. The final potential energy of spring is 1/2 k L over 2 squared. I think. Got a Burger King ad. I want a burger now. Shit, I knew I should have went with the burger patties. Personally, miss me with Burger King, McDonald's, really almost any fast food chain. They're all kind of overpriced garbage in my mind. This is not right. H squared. No, H is wrong. That's not H. Homemade burgers are the best. They can be. You're saying it's 3L over 2 at the final? I mean, that's what we want to solve for. We should define H instead as H beyond L. I think. So we would make this H plus L. I hope. And we want to solve this for H. The 8th KL squareds cancel. Get everything onto one side. Plus and minus like that. This doesn't have a factoring that I think of as obvious. So let's throw the quadratic formula at it and see what happens. I do think it makes sense for there to be two answers because it should be zero. It should be at rest at the very top and at the very bottom. Oh, no, 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 no. We're solving for H. That's just KL. All wrong, all wrong, all wrong, all wrong. This thing does factor. I retaught simple harmonic motion tape. In fact, I can't think of anything. It's ironic. Oh no. Makes you feel any better? The problems from this book are really challenging. I think I have a slight issue in my work where h equals 0 doesn't make sense. I don't think h equals 0 should be true, but let's just keep the math going anyway. Let's see what we get for the other answer. So h is mg minus a fourth kl. 8 2 divided by k. You could also say 8k, no, mg. There's no way this is right, dude. What? H squared? No, h is a variable I made up. The answer should involve h. Yeah, I mean, the spring's energy would be all kinetic. That's what you mean, right? That's what I think that means. What is mg over k unit-wise? Kg meters per second squared over newtons per meter. Oh, that is distance. Wow. So the units somehow miraculously do check out, but this just looks disgusting. It probably should depend on gravity, probably should depend on mass, probably should depend on K, and probably should depend on L, right? Maybe this is okay. But I hate it. Oh, you found instead of H plus L shouldn't just be H. Oh, oh crap, you might be right. Yeah, I was thinking about it wrong. If L is the resting length, it should just be H. All right. Well, that's unfortunate. But that logic does check out. Oh, the 1/8 there was also wrong the entire time. So I definitely I did multiple things wrong there. That 1/8 needs to be a 1/2. Okay, if we solve this for H. Okay, we'll just keep it like that. Orange hue, H is whatever length beyond resting the spring extends to at the longest. That's what we want to solve for. It's, I guess, like the distance they're asking for in this question. Yeah, the amplitude. Yeah. B squared minus 4AC. K times KL squared. I think I plugged that in right. Well, we have an issue where this annoying thing underneath the radical isn't going to factor. It was much nicer before when I was mistakenly doing the H plus L thing because the L terms canceled. Or like, just the constant terms canceled. That was wrong, but it was nice. Am I off by a sign somewhere? No. I know whatever we do find for H, we need to add to L to actually answer the question because they're asking below the ceiling. We learn about that at the very end though. Unless you want to define H's distance below the ceiling. In which case we want to do H minus L. That might help. It would avoid this disgusting quadratic. I think. Work done due to gravity should be mg. You're right with this, because I initially defined h differently, right? And I never updated it. Thank you. H plus L over 2? Yeah, okay, I like that. Good catch. Central, I'd say hi back to you, but I'm confused on who you're addressing. I'm just saying the potential energy, the gravitational potential energy of the mass, orange hue. So you never talk about your Dang, I was trying to avoid the insult that I knew was coming. But you flipped it around again and made it nice. Never avoid what's coming. And so I think there was a problem before where we can disregard gravity if you measure. Oh, maybe we're supposed to use that. Too late. I want to see what happens with this approach, but I think if you measure. You might actually be allowed to neglect gravity and if you set it up right. I forget how that's going to work. Dunda's Daisy's twin brother. Yeah, me and Central are twins. Look exactly the same. I don't know how Central looks, to be honest. You're this close to the answer. Let's see if this one works out, I guess. This looks like it's making the situation more complicated, unfortunately, though. Maybe it doesn't. Maybe the quadratic will work out. We might actually get a cancellation. You never know. That's how this quadratic looks. As far as I remember, it's when it was in number 6 right here. Explain why your result shows that a hanging spring can be considered to a spring in a world without gravity, provided the new equilibrium point, why not, is now called the relaxed length of the spring. So maybe we are supposed to use that result. for the sake of potential energy. No, I mean I think you might actually be able to use it here. I just don't know how else it would work. What you just solved in the space station? True. You have to be considering change in potential energy for you to be able to disregard gravity, I think. But there is something like that, I think. But I'm just going to do it this way. There's no cancellation. I was hoping there'd be a cancellation. Well, wait. There might still be. I need to distribute. No, wait. Minus 4 times a half k times minus. Oh, it doesn't cancel. There's no cancellation. Yeah, delta. Hey, Raven. Need to practice math, but I'm so sleepy. Yeah. I've had that dilemma before. Thank you. It's very it's perfect, isn't it? This line. And go skiing on the. It's not that bad. It'll still be cross country skiing. Okay. This doesn't seem any simpler. I'm going to throw this away too. I'm going to measure h from the ceiling. From I kind of know about, but it's more advanced than I've looked at. That's the entire thing that this mechanics book does. It's problems that are like it's a challenging book. Okay, potential energy of the spring 1/2 k L/2 squared as normal. Maybe to never actually open it. I wouldn't blame you. Plus mg h minus L/2. One half k h squared. I don't think this is going to be any simpler. Don't think he needs to kill. You print it so he needs it to kill spiders. That'd be a good idea right there. Let's play this as looping. Hey Moo, why not eliminate one unknown using the first sentence only? I don't know how that works. That's why not. Final, yes, thank you, Babia. Ugh, I keep messing that up. I don't know what unknown you can eliminate from the first sentence. Okay, let's bash our head against this quadratic a second time. KHL plus half KL squared. Okay. MG equals KL? Oh. We might use that. I mean, that realizing that might have been helpful when I... Let's see what discussing quadratic we get from this, and that result might be useful here. I didn't think about that. All right, we're solving for h. We have one h squared term. 1/2 kh squared. How many h terms? mgh. And that's all? Okay. Let's hope these constants aren't too ugly. An 1/8 kl squared, 1/2 kl squared. Wait, I need to think about what I'm doing. I'm subtracting mgh over to the right side. I'm taking 1/2 kl squared and subtracting an 1/8 kl squared. So we're going to get 3/8 kl squared. We have KHL that I missed. Ugh. Okay. We have minus KHL minus MGH. KL squared. Okay, I accounted for that term, that term, that term, that term, that term. It's just the 1/2 MGL which gets added. I don't like that I slashed through those now. No. No. That's an L. Why do you never select the thing that I'm clearly selecting? Oh my god. How? There. I'm literally nowhere close to the part of that K. This is ridiculous. Dude. Okay, you know what? Fuck it. That slash just lives there now. H equals mg plus kl plus or minus root. This is not good, dude. This is not good. Nothing about this is good. I mean, it sounds like we are expecting 3L over 2 somewhere as an answer here, but I don't want to use I don't want to use anything involving waves. We're not supposed to do that. Yeah, that's what I'm thinking about next. It's just that no, yeah, it will help. You're right. Okay. Let's do that move. TNT, yeah, not at all. What did I just do? Did I just delete the page that I was on? How? Okay, thank God we have undo. I don't know how I deleted the page instead of adding a new page. All right. So yeah, let's use the thing we use. Let's get everything in terms of KL here. Looks, I'm learning Turkish. Pretty cool. I can say hello, how's it going in 4 languages now? 5 actually. Oh, nice. Plus, I think that's what's happening here. I almost certainly did something wrong, but I'll find out the hard way. Let's just work out the constants separately. Or let's just work out the constant in my head. 4 minus 3, 4. Oh my god, okay. 4 minus 1 is 3. 3 minus 3/4. It's definitely a number, I can tell you that much. 3 minus 3/4 is 9/4. This question might need to return as the Ed Sheeran body double. Yeah. Definitely should not be quitting my day job here. The day job that I don't have, by the way. That looks like it's something, right? It's not nothing. That looks like delta. My L's are devolving. Or no, delta's upside down. I don't know what that looks like then. That's... Ooh, this isn't necessarily wrong. We need to think about it though. No, this is wrong. Um... Job you'd love to try out? I feel like teaching a community college would be pretty chill. Didn't ever time finding a job in earlier years. Oh, really? How do I get 9/4? I probably get it incorrectly. Because I'm doing 4 minus 1 minus 3/4. And 3 minus 3/4. It is 9/4, so stand by that. So I do think this should be 5/2L. If the right answer is supposed to be 3L/2 or 3/2L, I need this h to be 5/2L for how I'm measuring h. because we would need to subtract off an L to get the distance beyond relaxed length. You know what? I have a cheesy answer. I feel like this is the answer. I feel like this is how the book is going to do it. Um, According to something we did in problem 6, if you measure potential energy from the equilibrium point with the mass attached, you don't have to worry about gravity. And we are measuring L with the equilibrium point with the mass attached. So if we raise it by L over 2, it's going to go down L over 2 past the equilibrium. So it's going to go down 3L over 2. And I feel like that's all that... Do I help it? Yeah, of course I do. It's just what I'm doing in the downtime until someone has a question they need help with. Yeah, if you have a question that you actually like need help with, you can type it out there in chat or put it in Discord or something. Let's just check that answer. I feel like that's what the book is. I feel like you're not supposed to do some crazy quadratic like that. No, it was 5 over 2L is what I was getting for like the extended length. I don't think what I got is right. It was the crazy thing. Oh, that's a neat factoring trick. Hmm. I need a girlfriend. Who do you suggest? Does anyone in chat want to volunteer their mom? Come on, speak up. No, I don't know. You can't post on math homework? You should be able to. I don't know why you wouldn't. Is it giving you an error message? You can't press the post button? That's so weird. I feel like I've had people say the same thing, but they never really explained it. Oh, okay. Oh, it might be forcing you to choose a tag. I might have marked. No, I don't think I required that. I don't know. So y is just any position relative to the unstretched position of the string. You're interested in the solution involving a negative y. Ooh, this looks juicy. All right, let's try this problem. And you say the answer should be 1 over 24. Okay. Really? I feel like this should be 0. Oh my god, this is... I guess we L'Hospitals. This is a weird looking one. Just listen to music, YouTube music suggested by the audience. I've been thinking about doing a stream like that. I just feel like, at least for me, I feel like not enough people would be interested. Okay, you know what? For cube root of 8x, come on, dude, just, or come on, whoever wrote this problem, 2 cube root x. It makes the derivative a lot easier to think about for me. Times a third. Might be mistaken the book even though they're rare. I mean, I'm just thinking that the linear term on the bottom, I think, should be whatever, like, the best power of x it has is a half. And I'm still getting 0 from this. Because these are both going to 0. Let's we need to graph this because if it's not 0, I'm confused. Come on, you can't tell me I'm wrong yet. We haven't even graphed it. It's an interesting looking function. One over 24. That's step. I mean, 1 over. I feel like I should know how to estimate that in my head, but I don't. 0.04. Yeah, we're way below 0.04. This thing is going to 0. It must be mistaken the book. Oh, wait, is the title of that thread you love limes because it was making you write a title for it? Limes are pretty good. Yeah, it was a question from a book that Raven is using, I guess. Oh, you call limits limes. Oh, okay. I like it. I don't guess I'm kind of mentally done with physics right now. I'm kind of annoyed at number 9. I don't know what to do instead though. I want to work out 9 again on my own another time. Algebra? I haven't done algebra in so long. Alright, it's gonna be like the abstract algebra thing. It's gonna be bad, especially because that's on an annoying topic too. That's the annoying topic that I was referring to, Bob. You have permutation groups. Ugh. Dirac's notation? I've never heard of that. If it's Dirac, it's gotta be something weird. quantum mechanics? I haven't even seen it yet and it already looks terrible. What's up, Famished? Bras and kits or bras and kits? Brah. I didn't know bras were of this form. Who knew? Yeah, brocket. Sorry, like, how do you not laugh at this? Ugh. Yeah, go for it, Famished. It's cute. It's cute if it looks like a face, I guess. I was imagining a different thing. Anyway, that looks crazy. Let's just see what Famish has to post. Yeah, Raven. You had to teach it to the new batch. Ooh, interesting. Okay, maybe while Famish does that. I haven't done this in a long time. When was the last time you guys did a nerdle? It's like Wordle, but with math equations. You have to input a true math equation. And then it'll tell you what characters to typically do and don't use. So maybe let's start with like 12 plus 34 equals. I don't want to reuse 4. I want to use as many unique symbols as I can here. I feel like I had this figured out when I did these more often, or I had like a good guess, a good first guess figured out. Maybe division is the way to go. No, I don't know. 12 plus 43, does that avoid the issue? That's gonna be 55. Could just do 46. That'll be 58. Okay, sure. Math question? Okay, nice. Ooh. Okay, we'll put a pin in the nerdle here. Are you using matrices, Famished, or no matrices? Statistics or statics? I doubt I can either way, Ben. Statistics? I'll take a look after this one, but you haven't learned matrices, you're doing elimination substitution? Okay. All right, we can do that. Whenever there's three variables, it's a little bit tedious, but we definitely can. I think the easiest thing I'm seeing to try to eliminate first are the y's. I think we have to do the least multiplication there, because to make 3, 2, and 1 match, you have to multiply all of these up to 6. Watching you all night? Oh no, Bobia. Good morning? Oh, like 5 in the morning. Oh, geez. All right, well, if you're going to sleep, then I hope you sleep well. I'm going to take equations A and B and multiply them each through by 2. So that way we can get all the y's on the same page. So if we do 2 times A, we end up with 6x plus 2y minus 2z equals 16. And if we do 2 times B, or not to be, we get 4x minus 2y plus 4z equals 6. And now what I want to do is, Principal Presley, pick me up if I'm late. Oh God, okay. So I'm doing this to get rid of the y's. World friends. Oh, okay. So it's not like a you're in trouble thing. We want to get rid of the y's. And so C has a plus 2y. So if I want to get rid of the y's from this thing here, I need to subtract off a C. Just to, oh my God, Jed, you're smart. Ignore what I just said. Yeah. Sorry. Jed is a much nicer person. Just add a plus B off the bat. Oh wait, but did I still need that? No. Huh. Yeah, okay. Honestly, I would just do this with the matrix personally, so I'm a little bit like let's say like rusty. But Jet is a much better first step, which is just to add equations A and B. So I'm gonna add those up. 6x plus 0 plus z equals 11. Well, what am I wrong about? Oh my God, you're right. I'm not with it right now, apparently. Thank you. So now we have an equation with just 2 variables, which is nice. That's easier to work with. I guess you can call it 0y, but it's 0, so we can just rewrite it as 5x plus z is 11. But now we need a second. We do have 2 unknowns, so we need 2 equations to solve that. So now we should look at equation C and figure out a way to get rid of the y from equation C. So I'll show up to class. Good luck, Bob. Yeah. And so I think what we want to do is take either A or B, it doesn't matter which one, solve it for y, and plug it in for that one right there. And I'll show you what that looks like. So if we take equation A, just choosing one randomly, that's 3x plus y minus z equals 8. Let's isolate y. So I'm going to subtract 3x from each side and add z to each side. Minus 3x plus z. We get just y equals 8 minus 3x plus z. Great. Now we take equation C, just write it down as presented. And we know what y is, so let's plug that in for the y inside equation C. And all this is in the name of getting a second equation just with x and z, so we can use this other one over here. So we get 8 plus 2, and then y is now 8 minus 3x plus z minus 3z equals 5. X, so let's attribute the 2 out. X plus 16 minus 6x plus 2z minus 3z equals 5. combine like terms. X minus 6x is minus 5x. 2z minus 3z is minus z. 5 minus 16 is minus 11. Oh, what am I answer? It's got to choose something and go with it though. Yeah, I'm doing a mix of substitution and elimination here, I guess. Famish. I'm kind of doing whatever seems to be the easiest. Oh, that's not good. How's it? Oh. They're dependent. We should get something weird like this. Okay, so the issue that I've run into here is that the second equation involving x and z, we can multiply it through by -1. And it's the exact same as the equation we already had. So that's actually we think that means that we suspect that something is up with this. Like we're probably going to get it's in okay. Sounds good, Ben. I'll look at it after this. Because so these two equations do agree with each other. I suspect we're going to get infinitely many solutions from this because it's possible to instead get one of these equations like 5x plus z equals 12 or something. Then these equations would not agree with each other and you would say it's inconsistent. But it was 11. So I think we're going to get infinitely many solutions. And I feel like I'm looking for a better way to show that. Oh, I think B plus C equals A. So I'm noticing that on the right side we have 5, 3, and 8, and that 3 plus 5 is 8. So B plus C is okay, good. Finish. I'm glad that we came to a conclusion here, but I'm just looking for a way to show it in a little bit of a better way. That's why I'm still like trying to explain something. But if you already get it, then that's awesome. A minus B minus C. I assume it's just gonna be 0. If we do this, we get 3x plus y minus z equals 8. But this is just A. So in reality, we have 3 unknowns, but only 2 equations. So you're supposed to have fun? Oh, okay. If you're good with it, then I'll leave it alone. But yeah, with like linear algebra, you can get how those solutions should look. And I guess even without it, we probably still could, but they're not asking us to do that, I guess. Just the number of solutions. I'd say it's dependent in infinitely many. All right, Ben, let's look at your stats. Intermediate algebra and linear algebra go hand in hand. Yeah, I'd say linear algebra definitely builds on intermediate algebra. You learn kind of a cooler way to generalize how to do this type of question here. And when I say generalize, I mean like, what if you had 5 equations and 5 unknowns, or like, you know, any number of unknowns and equations that you want that are of this form. You can talk about kind of all of them at once. That's the thing that you probably one of like the first things that you like start working on in linear algebra. And actually, something I was always confused about, the thing that makes it linear algebra is that all of these are just x, y's, and z's. It feels like if you threw an x squared in there, it's no longer linear, and you have to do, like, linear algebra just doesn't cover that situation as far as I know. Or if you had like a root or a sine or cosine or something. That's always something I was like wondering what makes it linear, and that's what it is. The fact that they're all just a single x or a single y or a single z. So wait, Ben, are you still here? I assume the task is to prove this is a PDF. Yeah, you have to do a double integral to show the answer is 1. I believe the question is, oh, you are here? Okay. A closeness function? I assume that's a weird translation, but it's pretty common thing in stats where, like, you know, prove this thing is a probability density function by double integrating and showing it you get 1. Hey, Scorpra. So we need to figure out what these bounds are telling us, I guess. Phone's coming after I finish matrices from height 4. Nice, Danish. Yeah, at least the way that I went in my stats class is we call like the question would be like, prove f x y xy is a probability density function. Yes, that's how I remember it. So to square rotated 45 degrees? Is it? I think it's some weird parabola thing. Call me when it's gone. This part of stats, I don't remember it well, but I do actually kind of enjoy it. I think it's basically just a multivariable calculus problem at this point. Like, we just need to integrate this function over its domain and hope we get 1. I mean, if you have something pre-made, then sure, but... Oh, the region to integrate over. Oh, yeah, that's a good idea. Yeah, we should... So I was just gonna work with it, like, algebraically. But that might be better. Ooh, that's... Okay. That is an image. Oh, these are probably level curves. over the domain. And that is that 45-degree rotated square that you were saying. Yeah, I was just thinking like polar coordinates, but it's not quite so clean. Ooh, you're okay. That's a different change of variables. Okay. Well, I mean, I want to figure out the bounds. Or maybe, are you making those based off the? Use the Jacobian, which I don't remember how to do. That feels so right, Fenbox. Figure out the garbage during the exam. Yeah, I would need to do a lot of studying before I feel comfortable. Doing this on the fly like that. Okay, Fenbox's idea sounds great though. Doing a change of variables with u equals x plus y and v equals x minus y. That'll make the bounds super easy. In ellipse? I don't know. Maybe. Jacobian. I shouldn't look at Wikipedia for anything. Go away. Oh my, 30 times. Claim your free account now? How about no? Are you kidding me? All right, this website is dead to me. I'm not doing with incognito. I'm just going to a different website. To be fair, these are the... There we go. Except we need it for 2 dimensions, but I assume it'll be the same thing. I don't think Paul does it. Does he? Oh, I shouldn't have doubted Paul. Oh, based Paul. Okay. Never doubt Paul. I need to take a screenshot of that. No, I let Paul down, as it turns out. Okay, so the glorious redemption of Paul. Yeah. I feel like if I was stronger on multivariable integrals, I wouldn't need... I could feel like I could do it without a change of variables, but I think this is kind of slick. Some shill you are. I know, Fembox. So we want the determinant dx du. Ugh. Aren't these all 1? I guess some of them are -1. So dx du is just 1. dx dv is also 1. dy du. No, these are all 1, aren't they? Sounds good, Ben. We'll do. I guess maybe that's supposed to happen because they're all like just linear. Coffee tastes better if you haven't slept. Oh, are you just gonna power through it, Bobia? You're not gonna try and get at least like a couple hours? Or an hour or two? dydb. This might be -1. Yeah, okay. So we do get a -1 in there. -1 minus 1. Oh, it's -2. That's our Jacobian. Watching but no sound? Okay. So, the double integral 3/2 x plus y squared dA is equal to the double integral 3/2 u squared times -2. Let's just say du dv. V. Make it more angular. It'll be fine. He said while shaking, oh no. And so if x plus y goes from -1 to 1, then u goes from -1 to 1. Likewise with the v. So -1 to 1, -1 to 1. We can integrate the u's. U. Oh, I forgot I dropped my -2. There we go. Shane. Thank you so much. Nothing much with me, Shane. How's your stream? Were you doing office hours? Thank you so much. Welcome in, everyone. I'm for anyone who's new, I'm Don. I do actually like math help streams. I also play games. And we're working on this kind of crazy... It's a statistics problem, but it's like theoretical statistics where you have to use a lot of like calculus. So we have a function here that we have to prove is a probability density function. And so we have to do that with a double integral. Hope your stream went well, Shane. Oh, I was just... I have an alert of huskies just going wild because it makes me laugh, and like there's a lot of videos on YouTube of huskies just like screaming that like I just find really funny, so I made that an alert, and that's what you heard. And tell you how happy I am that people like you exist. Aw, thank you, Shane. For what it's worth, history is like a side interest or hobby of mine. I got in the habit of going to the library and just checking out random history books, so I really enjoy your stream too. So I'm gonna have to do that. I probably just commit some buku. Oh, I think this is fun. Benvox, I think I suggested a really clever way to do this without a ton of pain. I love you think it's fun. I'm happy. I kind of want to do it a different way after I solve it once as well. If this gets the right answer. Basically, we're hoping that this integral here, we just want to end up with 1. Well, double integral. Our final answer, it should be 1. For anyone who's here on my end, by the way, you should check out Shane. He has an awesome stream. He streams about like history and sociology and things like that. I think it's super interesting. I love to learn about it. Bobby, I've looked at JE questions before, and I do not enjoy them. Uh, they just feel like they're all trick questions that use very vague identities. And I don't think I've had a JE question that I enjoy, to be honest. We're gonna problem heard my cat beefing with the other cats, and I heard huskies, and like, what is happening? Oh my god, yeah, the animals are having a war. Um, but, you know, I've been behind on my history reading. I went to Japan in November, and so I really want to learn more about their history because I loved it there. So that's probably that. I was looking for a book, but I never went through that. Actually, like checking one out. Jealousy, yeah. It was my first time out of the country actually. Um, and it was just an amazing time. I highly recommend it. If you time it right, the tickets you can get plane tickets for like $500 round trip if you're willing to do a budget airline. 10 streams of Japanese history. Ooh, are those posted somewhere? So I would love to go back through and watch them. I have heard of that, Bavia. No, I've gone down that Wikipedia rabbit hole. You save all your VODs? Oh my god, okay. I'm gonna have to look for that then. Because I am very interested. Thank you for letting me know. I'm getting 2. No, I'm getting 4. -4. That's not good. Picking your preferred social media. So you have to wait through 200-ish. Yeah, I'll take a look for what discords we're on, or even just like links in here chat are turned on, but I'll take a look at the social media you have after the stream, I guess. Divide by 2 rather than multiply by 2. Oh my god, Stevie, you're back and you retracted something before I could even read it. Okay, that at least I could read this message. I dual stream to Twitch and YouTube, so if anyone here on Twitch is confused, I'm talking to someone who just popped up on YouTube. Woke up from math coma and looked at my favorite math YouTuber. I also love Japanese culture. Oh, nice, Stevie. Well, welcome to the world of the welcome to the waking world, I guess. We've had the inverse of the correct Jacobian. Really? I think you guys are oversimplifying it based on the solution the professor gave. You probably aren't supposed to use the Jacobian in this class, or maybe they don't expect you to know it. Oh, and you're still retracting it, Stevie? No. Ugh. You know, hiragana and katakana. I'm learning Japanese on Duolingo. Oh, nice, Raven. How do you like it? I've done Duolingo for Spanish, and I did not like it at all. I wouldn't be myself if I didn't. Fair enough, Stevie. You love it? Okay. Why are they half? I don't get that. Oh, hello to you on YouTube as well, Bobby. Japanese Duolingo is a good addition to balanced diet, including other sources. Okay, fair enough, Shane. To be honest, my plan was to look into like a community college to see if there's a class around me. I assume there would be. So more challenging to learn other kinds of letters. I gave up on Italian because it wasn't entertaining enough. Oh, it wasn't enough of a challenge? Uh, nah, I struggle even with like Spanish, so looking for getting them only really. So yeah, exactly. I didn't like that Duolingo doesn't teach you the grammar. Like I want to learn the grammar rules first and then get into making sentences. But Duolingo just kind of throws you in the deep end. It never actually teaches you anything, it just starts asking you questions. This is my experience. Oh, you have to get, okay, so what I was doing here wasn't right. Sentence solution. Yeah, let's see then. I imagine he does not use the Jacobian, that's why it's more complicated. You know, actually, that reminds me. In Japan, there was on the subway, there was an ad for Duolingo involving that freaking bird mascot they have, just like going to any end just to track people down, like bursting through crowds of people on the subway to like tell the one person to do their Duolingo. The person like wakes up in bed next to the bird mascot, like that. That bird got places. Yeah, then it's what you do for an arbitrary change of variables in multiple dimensions. Like, if you've seen like if you have like a polar integral, if you have the like double integral x squared plus y squared dx dy, you could change it to polar. Like x squared plus y squared is r squared, but then you get an extra factor here that's like r maybe sine theta drd theta. The Jacobian gets you that extra factor there. I might have the exact example slightly wrong. Okay, then that, yeah, we probably shouldn't use the Jacobian then, but that's basically what it's doing. It gets that extra factor. I imagine the solution does not involve change the variables. It's not like that. Not anything that would require Jacobian. Do harass people. I want to stabby that bird. Yeah. Oh yeah, the bird's name is Duo. Oh hey Bob, I paid them many millions of dollars, Bob. It's been getting much more expensive to pay people to watch my stream. Let me tell you. Oh, it is just RDRD theta. Okay, maybe I'm getting mixed up with like spherical coordinates where there's a sign in there. Zero past people that have multi-variables at all? Oh my god. Yeah, that's terrible then, Ben. I want to keep my family safe from that bird. Yeah. Why did the multivariable function break up with its Jacobian matrix? Because it couldn't handle all the partial pressures. All right, Stevie. My god. Change your phone language to Japanese. That helped. Ooh, interesting. Oh god, we have. That's annoying. You have to use the absolute value. Uh, that's cool with me, Shane. If you want, I can. If you're in, I assume you're in like the TKF Discord. I could look for you there and send you a message too, if that's easier for you. Yeah, I think Fembox's thing is easier. Shoot Arsenal for being too rude. Oh, I might have seen the conversation. I imagine someone would think it's too rude. When I read it, I didn't have that feeling. It was definitely like frank, but um okay. Well, thank you. If not, wait. If I disable streamer mode, I might be able to. Oh no, I see you. I'll send you a message. Hey. Okay. Let me put streamer mode back on so you guys don't hear notifications popping off. Okay. Ben, thank you so much for the prime. Holy crap. I appreciate it. Okay, sorry, I'm like thinking about 3 different things at once right now. If you want to learn Japanese, I think lessons from Japan Foundation is pretty alright, and it's free. The ones from NHK so get someone to JF. Okay, good to know, Joseph. Wait, so are you still in Japan right now, actually, or where are you in your journey? Jacobian is the absolute value? Oh, it might be. Oh, nice. I'm going to save these links for later. Fly back later tonight? Oh, wow. How was it? Or like, I mean, I guess I'd be interested to hear about your entire trip to be honest, but did you get your fancy nail clippers? Artists having this absolute value thing is super weird. I want to understand both of these ways. Oh, nice. Got it. Oh, you do a thing where you highlight your VODs. Okay. Got nail clippers. Shopped a lot of skincare products, especially eczema sheet masks. Oh wow, dude, you're gonna be very well groomed. The Twitch loophole. I've heard of that. I haven't bothered to do it myself. I just dual stream to YouTube because they just do it automatically. But that does seem like another way, or another like decent way of doing it. Move them all over to YouTube. It's a long process. Oh god, yeah, that would be annoying. Japan is so ahead of the United States? I mean, I don't know. I think every country is ahead of each other in some ways, and not in others. Well, that's maybe kind of a diplomatic answer. Oh, this is just terrible, though. You're supposed to do this, Ben? What is happening from this step to this step? A gene scanner class corrects our professors. Was able to get the correct answer. Oh my god. They're doing some crazy factoring trick here. They're noticing there's a 1 minus absolute value of x cubed in each of these things when you multiply them out. And that you have to get 2 in parentheses 1 minus absolute value of x cubed and canceling with that 2 there. But also somehow you get twice of something over for the remaining terms. I don't know. All right, see you, Bobia. Good luck with your class. So problems in the garage will always be done by hand. So we have 4x4 issues with imaginary numbers. Oh, they are grilling you. And you still have to multiply out a cubed. This is terrible. This is why a change of variables is way better. Oh, really? Maybe I'm behind on that conversation in TKF. Or maybe I don't remember it. Ugh. Burn is writing scathing feedback for the course. Yeah, this is a lot. Hey, Hitch Treasy. Welcome in. How's it going? To be honest, with that entire server, I already just kind of like lurk. I feel like I should engage, but I don't know. I just tend to be a lurker. It's going good for me too, Hitch Treasy. Thanks for asking. See you, good Raven. Good night to you. If you have a question, feel free to let me know, Hitch. If you're just here to hang out, that's also very welcome. Right now we're working on a stats question. Basically proving that this function right here is a probability density function. Just hanging out, sounds good. And we're looking through a solution for this problem, and it's kind of crazy. Like, in a perfect world, they should just make you set up the integral, sure, but then let you use some kind of like Wolfram Alpha or, you know, some type of program to do the actual calculations for you and get 1 on the other end. Because this is just like, that's the actual purpose of the problem. Like, doing all these crazy tricks here is terrible. Okay, it might be good for partial credit. Stevie, I am an applied math major. I graduated 5 years ago? 5.5 years ago? It's the same when you studied that there's just never enough time for these exams. No, the university I went to was, it felt too relaxed, to be honest. Things would happen where like the professor goes to assign homework, the other students in the class complain about how much homework that is, and the professor actually says, oh, okay, let me remove a few problems. And it always felt crazy to me that students would even ask that and that a professor would agree to it. Like, I don't know. But yeah, I like the school I went to was not intense at all. Professors in lit algebra don't check the inverses we have to find. Oh no. All right, Shane, enjoy your food. Thanks again for the raid and for the links. Hope you have a good weekend. Skip the class fast. We really don't have homework. Remind the teacher of it before we dismiss Friday afternoon. Yes, Stevie. Okay, this is I'm not interested in understanding this middle bit. I'm interested in understanding this absolute value business and setting up the integral. That's just terrible, man. Yeah. Well, yeah, you're right. I should look at this more. Am I combining a foreign language with math? Nope. Oh, well, actually, yeah. Ben is studying in Danish. That's the word. So we're taking x to go from -1 to 1, which means y goes -1 plus the absolute value of x from 1 minus... What? Why? That's so weird to me. When I was working on my head, I didn't think we would need absolute values to be involved. Spirit to all of us, yeah. I feel like it'd be easier to just restrict the area to be in the first quadrant and then multiply by 4. Draw the regions. Oh, okay, yeah, you're right, Zone Ranger. That would give you that diagonal square, I guess. Because yeah, Felix earlier said it would be a diagonal square. I don't know how they... that solution makes it look like they're doing algebraically, which I don't quite get. But the first equation would tell you... How do we want to think about this? -1 minus x is less than y is less than 1 minus x. 1 minus x is like that. -1 minus x is like that. The second equation would tell you the y is negative. That's annoying. Then you multiply through by -1. No, don't do that. Like that. That's an x. That's a terrible x. Should we draw that x? 1 plus x is like that. -1 plus x. I did this wrong. Yeah. Oh yeah, Felix, you were just saying the same thing with like just doing in quadrant 1. I didn't put that much thought into it being an even function. I should have checked that. I was just thinking only in terms of the region. Wait, 1 plus x, it is that. Did I do something? Maybe I did one of these wrong. Because -1 plus x is this. 1 minus x is this. Okay. Yeah, so it is just that basically like rotated square. So you could do, because even with both x and y, as Fenlock said, you could just integrate in quadrant 1 and avoid all this absolute value business. In which case your integral will be 3/2 x plus y squared dx dy. We multiply by 4 on the outside. If I'm doing x's first, x is going to go from... Maybe we should do y first. Y is going to go from 0 up to the function 1 minus x is this line. And then x can simply go 0 to 1. Now, it's still going to be a super annoying thing with cubes, but you avoid the absolute values on the bright side. It's partially even and partially odd. Oh, does this not work? I kind of assumed it looks symmetric because you can like switch x and y, I guess, without changing the value. That's probably not a good thing. The odd part we can just throw out. I don't know anymore. I'm just curious to see if this gets the... I just feel like this should work. Maybe I don't have a reason for it, though. You could definitely, instead of assuming they're all equal, you could do it. You could do 4 separate integrals. 1 for each region. Or maybe I'll do it in 2. I bet you can do it in 2. Yeah. But I feel like that should work. Integrates to 0 by symmetry of the region? Really? I'm just going to take your word for it because I don't feel like thinking about it. If you integrate with respect to y, 1/2 x plus y cubed from 0 to 1 minus x. One half x plus 1 minus x cubed like that. Oh, that... This feels too nice. This isn't painful enough. I don't trust this. Seriously? I know, Ben, there must be pain and suffering. Let's see if it gets 1. You're not doing math if you're not going through pain and suffering. Oh wait, no, okay, no, it's okay. No, it's not right. Huh. You must commit seppuku if you don't get this answer correct. Oh god, the stakes are high now. Can you quickly say how evil our professor is so I can record it and include it on my exam feedback? This is an evil, evil question. That's way too complicated. Here you go. Also, remember to subscribe to twitch.tv/. I don't know what's wrong with this. Um, Thank you for the follow. I need to... Dude, this activity feed only works half the time, I swear. Flask, thank you for the follow. Hello to you too. Welcome in. Is there music playing? Yeah, it's just quiet. I think it's a quiet part of a song. It's starting to ramp up a little bit. Try x squared plus y squared. Was it above y? That will work. Oh, okay. But I mean, x squared plus y squared isn't the problem though, right? Yeah, I'm just gonna leave it as this for now and assume it's just a quiet song or something. If it keeps on being quiet, though, I'll bump it up. Because I think before it was okay. Okay, so... There's got to be some type of symmetry you can take advantage of here. But... you could also just bash your face into the problem. And that's also fun. That one down there is x minus 1 to 0, 0 to 1. I don't know why I'm going clockwise. That's kind of sacrilegious. But you can do this in 4 separate regions. Actually, this is stupid, man. This is really stupid. Because you're going to get different integrands for all these. You can't really reuse any of your work. I don't like this either. I just hate the absolute value business. I can see where it comes from with this, but just the integral itself is just so hard. I'm gonna bump the music up a little bit. The entire song is quiet, apparently. I hope it'll be too loud on the next song, but we'll see. Hey, Punching. How's it going? The minion emo, is that what that is? Oh my god. Maybe the first minion emote I've seen on Twitch. Going good and or bad. All right. But there's a 50% chance of that being a good thing. Do you have a question today, Punchin, or are you just chilling? Depends if there's a direction with that magnitude. Yeah. Chilling, trying to watch some lectures? Alright, nice, nice. Okay. I don't have a better way to okay, well, the good way to do this problem is with the change of variables that Fenbox suggested, but it takes a little bit of... It's not quite exactly how we wrote it here. I think that's the best way to do a change of variables. If you don't have a change of variables, I don't have a better suggestion than the solution, which is terrible. The only thing I think of is to split up into 4 different regions and do this. And that's also terrible. I want to make the change of variables way work just because I want to see it. But I don't have a better way of doing this than the solution, unfortunately. Okay, so we want x as a function just of u and v. We know that y is x minus v. Okay, so that's where you get the x is equal to 1/2 u plus v. That means y is something, I'm sure. It's not nothing. One half u. Oops, I forgot my u. Minus a half v. Man, I love Holonomi's emotes. Or is it Holonomy? I don't remember how you pronounce it. I haven't said hi to him in a minute, though. I have time catching his streams with the time zones. Okay, so we do have the proper versions of x and y now. What's the Jacobian now? Dx du is a half. Although Skype is these hasn't streamed yet this year. Oh, interesting. Okay. Dx dv is a half. Thanks for letting me know. Dy du is a half. Dy dv is minus a half. Is that what we're saying? So we get minus a quarter is minus a half. And I do think it's going to get absolute valued. Wait. This sub isn't the same now. It's 3u squared. No, it's 3 over 2u squared. No, it's 3. No, it's something. It's not that simple. Yes, it is that simple. It is 3 over 2u squared. U still equals x plus y. Okay. And so that means we have a 1/4 out here. Which means we have a 1/4 out here. It was a roller coaster. I like keeping people in suspense. Was it? Wasn't it? No one knew. Exactly. It's anybody's guess. 1 minus -1. That's not even 2 either. It's a half now. No, that's a half. One. Okay. Edge of my seat. Yeah, this is some intense math that's happening here. I don't blame you, Casey. That is so much simpler than trying to integrate it directly. If you know how to do it, which clearly I don't. Oh god, we're going crisscross applesauce. It's time. Yeah, I mean, this isn't something they would teach you in a stats class. But they shouldn't expect you to do an integral like this in a stats class. They should let you use a freaking computer. But yeah, I'm sorry, Ben. Like that, like this thing is like the best suggestion that I have doing the change of variables. But since you're not probably not expected to use that, splitting up into 4 regions is the only other thing I can come up with. And I think that's about as tedious as doing it all in one as the solution does it. Ugh, some of these steps are just disgusting. Oh, I see how they get rid of the absolute value. They take the integral. Oh my god. They changed the lower bound to 0 and multiply by 2. According to the TI Inspire, yeah. My biggest challenge is understanding when to use what math for each problem, especially in real world. For example, I can use an integral to calculate area of a square. Ha. Yeah, that's the issue when you get to the real world. It's like, where do you even start? Because in the context of a class, you have like you can expect to have to use things that you learned in the class. All right, well, I think we can all agree this problem is disgusting. I think we'll give that one a rest. I did start a nerdle, and I have to finish the things that I start. Because I don't think we have a different question that's waiting anyway. It is addition, but the plus is in the wrong spot. The equals is in the wrong spot. What if we do say 4, 1, 3 plus? That can't be right. We don't have enough room. What if we do pretty unattractive as far as problems go? Yeah. I get that problem like a 2 out of 10. Really looks I need a Jacobian practice. Yeah, I mean, calling that change of variables is a great spot. How is this possible? Oh, you know what it is? No, you don't. I think it's 2 digits plus 1 digit equals 3 digits. I don't know what else it could be. So what if it's, say, 4 plus 97 equals 101? No. It's not 1 digit plus 2 digits. Yeah, purple is correct, but wrong location. Black is, it's nowhere in the equation. blue or green or whatever color that is right symbol in the right spot. So we know the plus is here no matter what. So the equal sign, what? Oh, wait, I forgot you can chain them. You can do plus, minus, or plus times. There could be multiple operations. I think the equal has got to be there. We need to test 3. Let's start with the 7 there. We need a 0 somewhere. Seven plus 13 minus, that's 20. That can't be right. 7, there's exactly 1 1 as well, because we have 1 purple one and 1 black one. So there must be only 1 1. We can do 7 plus 10 minus, no, we can't. We can do 3 plus 10 minus 7. 6? But we can't have 6. This is called Nerdle. Stevie, it's like Wordle, but with math equations. I started it, but before I just want to like finish it because I can't handle not having it finished. It's on nerdlegame.com. I used to do these a lot on stream. We could do 3 plus a single digit. Why would we? 3 plus 7 is 10 minus... Oh. We could also... I'm not even thinking about multiplication and division. I don't want to think about multiplication and division. We could do this. Sequences and series predictions? Maybe. Oh, we're so close. So we have exactly 1 0. We may have more 7s. Really? No more 0s, no more 1s, only 7s. What? Seven plus 7 minus 14. Oh, nice zone. Yep, there it is. They have crazier ones too. They have a binurdle, a quad nurdle. That one's new. Where you solve 4 at once. A cross nurdle. I don't know what that will be. You know what I haven't done in a long time? I haven't gone on the big old like math Discord and looked for problems there. Let's at least do a quick scan. I might just wrap up the stream if I can't find something. But let's see if we can... GTA for nerds. I'm checking it out. Go for it. Power sets, I'm okay. I'm looking ideally for a thread that doesn't have too much conversation already. There actually aren't a ton of threads open. Just gonna... Okay, they closed it. Dang it, I was hoping there'd be more. Find the limit by bounding without using binomial expansion on the cube root term. Um, two n plus 1 over 2n plus 2. Compute the middle limit by bounding. I don't know if the middle limit is just a piece of this entire thing or just the entire thing. I assume the entire thing. But I don't know how to do it with bounding. See what else is out there. Midnight Math, thank you for the follow. Got a Teenage Mutant Ninja Turtle asking for help. Oh, the Navier-Stokes equations? Yeah. Let's try it. Damn. I don't know what else to work on. I mean, maybe we'll just call it. My background in math? Oh yeah, Midnight Math. Hey, welcome in. I have a bachelor's in applied math, minor computer science. Applying to grad school for applied math. I've been a tutor at a community college, and I tutor some friends on the side, or like friends of friends. But yeah, that's basically my background in math. I do see that you're new here, and if you're curious about math on Twitch in general, I'm definitely not the only one. There's always people around in chat who have quite a bit more background in math than I do. And also there's other math streamers out there too who also are a lot more qualified than I am, but everyone on the list does math help in some form. So whenever I see a new person, I always like to let them know that there's more than like just me out there. When asked what your background is in math, no one asks how is your background in math. That's true, Central. I have the PhD in math probability. Just curious. Oh, nice. We were just doing a it's really messy, but we were just doing try to prove that this function here is a probability density function. And it's kind of a crazy integral because the person who asks it isn't allowed to, or they're not expected to know changes of variables for this type of integral. Yeah, so we proved it integrates to one with a change of variables, but they were expected to not use Jacobians or anything like that. They had to integrate it directly, and that is crazy. But yeah, Fenbach spotted this nice change of variables here, and it works out pretty quickly. So I still have I don't have the solution up. Well, let me, there we go. Control T for the win. They were expected to do it the old-fashioned way and integrate it directly. And there's a bunch of crazy steps in this. Have I tried R programming? A tiny bit when I was studying Stevie. I barely used R though. Lame? Yeah, it is lame. There's cobwebs ranging from some triple acceleration equations all the way to eigenvectors. Oh, centripetal. um. Art does seem a little weird. I haven't messed around with it enough though. I think I'm gonna call it here for the day though. I don't have anything else that I want to do particularly. When I started grad school, late night studying for qualifying exams. Oh, that makes sense, yeah. Statistical garbage, R is. It seems like a commonly used program. I don't know. Yeah. I think we're wrapping things up here. On YouTube, I'm just gonna shut the stream off, and on Twitch we'll look for a raid. So Stevie knows who's here on YouTube. Thanks for being here. Yeah, it's all used in data science. But yeah, see you YouTube.